All right, let's talk about something that's absolutely crucial for every single Salesforce developer out there, Apex Security. Because let's be real, it's not enough to write code that just works. It has to be safe for everyone who uses it.
So, picture this. You've just finished a new piece of Apex code. You run it, and it works perfectly. For you, the admin. But then you have to ask the really important question, what happens when a regular user, someone with a completely different, much more restrictive profile, runs that exact same code? Is it still secure? And that's where we hit this fundamental, kind of surprising concept. By default, your Apex code doesn't always care about user permissions. It often runs in what's called system mode, which means it can just bypass all those carefully configured permissions you've set up, creating a massive potential security gap. So let's dig into that hidden security gap, shall we? Because to really fix this, we first got to understand why it even exists and what context our code is actually running in. The main culprit here is system mode. You can think of it like your code is running with a master key. It has the power to see and do almost anything, completely ignoring who the user is that kicked it off. This is precisely why we, as developers, can't just sit back and assume the platform is handling security for us. Nope, we've got to take control ourselves. So how do we take that control? Well, the first way is to get our hands dirty and manually check for permissions right there inside our code. Let's take a look at the toolkit we have for that. Salesforce gives us this really simple but incredibly powerful set of methods in the Schema class. As you can see, there's one for each of the core actions you'd want to do. Can the user access this? Can they create it, update it, delete it? You can think of these as little security checkpoints that you build directly into your code's logic. Okay, let's see what this looks like in some real code. Before you even think about running a query on the account object, you can wrap it in a simple if statement like this. That is accessible method. It basically acts like a bouncer at a club. It stops and asks, hey, does this user even have a ticket to see the account object? If the answer is no, the query doesn't even run. Simple as that. And we can get even more specific, which is super cool. We can drill all the way down to the field level. So in this example, before our code tries to change the rating field on an account, it first checks is updatable. This is exactly how you make sure your code respects field-level security for every single user, preventing them from changing data they're not supposed to touch. Now, those manual checks give you amazing, fine-grained control, but yeah, they mean writing a little more code. So what if you want a more automated approach, a more hands-off way to do this? Well, that's where Salesforce's built-in defenses come into play. Think of these as automatic security guards for your code. So, Salesforce gives us two main tools here, and they're pretty easy to remember. For reading data with a SOQL query, we can just add a simple clause. And for writing data with a DML operation, there's a specific method we can use. So one for data coming out and one for data going in. For reading data, seriously, it's this easy. You just add the phrase with security enforced to the end of your query. Now, here's the key part. If the user running this code doesn't have permission to see the account object, or even just the phone field, this query doesn't just fail silently, it stops everything and throws a security exception. It's a fantastic, super clear way to enforce read access. Now, for writing data, the approach is a bit different but just as powerful. Before you update your records, you pass your list of accounts to this security.stripInaccessible method. But instead of throwing an error, it does something really smart. It just quietly removes any fields the user isn't allowed to edit and then hands you back a sanitized list of records that's totally safe to update. Okay, so we've got our manual tools, we've got our automated security guards. Now let's put it all together into a practical playbook, something you can actually use every single day to write more secure code. So, for any update operation, your secure workflow is really just a simple three-step process. First, you get the records you want to update. Second, and this is the most important part, you run them through stripInaccessible to get that clean, safe version. And only then, for step 3, do you perform your DML on that sanitized data. It's a pattern that will save you from so many headaches. And of course, this applies to creating new records too. It all comes back to this one core principle. You have to verify permissions before you act. You check is creatable on the object, you check it on the fields. That right there, that's the foundation of secure Apex development. Whew, we've covered a lot of ground. So let's boil all of this down into an essential bite-sized checklist that you can start using like right now. All right, here are your key takeaways. First off, just always check for permissions in any code a user might touch. Second, use those schema methods whenever you need that really fine-grained conditional logic. Third, lock down your read operations with security enforced. Fourth, before you do any DML, clean your records with security.strip inaccessible. And finally, please remember this. Secure coding is not an optional feature. It's absolutely essential for building professional, robust applications.
So, we're at the end. The concepts are clear, you've got the tools, and the playbook is ready to go. The only question left is the one for you. What's the first piece of your own code that you're going to go back and secure?